Honors Algebra 2 Pre-Calc. We are still doing 2.4, which is operations with functions. So before we move on to composition of functions, I want to talk about a common error that comes up a lot, right? So if we can sort of try to troubleshoot and get ahead of things before we make mistakes, that would be awesome, right? So one really common mistake that people make is confusing f of 2, which is this f with a 2 inside the parentheses, with 2 times f of x. So f of 2 means replace every independent variable x in the expression with a 2, right? And 2 times f of x means multiply 2 times the entire f of x expression, right? So let's go ahead and walk through that. So in E3 and P3, I've given you an f of x and a g of x, and that's what we're going to walk through. So in E3, f of x equals 6x squared minus 3x plus 1, and we're going to go ahead and find f of 2 first. So f of 2 means 6 times a 2 squared minus a 3 times a 2 plus a 1, right? And technically the square should be out here, not that it makes a difference. Okay, so that's going to be a 6 times 4 minus a 6 plus a 1, right? So 24 minus 6, which is 18, plus a 1 is 19. Okay? Cool. So 2 times f of x, though, will be 2 in front of the entire f of x equation, or expression rather, right? So I'm going to distribute that 2, and I'm going to get that this is 12x squared minus 6x plus 2. So notice the difference between finding f of 2 and finding 2 times f of x, okay? So I'm going to try the same with P3. Feel free to pause me if you want. So g of 3 is going to be a 3 times this 3 squared minus a 5 times 3 plus a 2, right? So that's going to be a 3 times a 9, right? So it's a 27 minus a 15 plus a 2. Well, that's a 12 plus a 2, so I get a 14. 3 times d of x, however, is going to be a 3 times 3x squared minus 5x plus 2, right? Which means that when I distribute the 3, I'm going to get a 9x squared minus 15x plus 6. So again, notice the difference between g of 3 and g of x times 3, or 3 times g of x. So those are very different things. All right, so let's talk now about composition of functions. So composition of functions is when you put a function inside another function. So on your textbook, you can find this on page 113, okay? So composition of functions. Again, it's page 113 if you're following along in the textbook, okay? So let's say that f and g are functions of x, right? F with this little open circle of g, right? F of g of x. So the way we read this is f of g of x, okay? What this actually means is f with the g of x as the input inside f of x. So even though this is how you actually read it, right? So this is how you read it if you were going to read this out loud, right? If you were going to read this aloud, that's how you'd read it. But what I want your brain to think is f outside g. So when you see FOG, like that little fog, like it's a tiny little raised O, sort of. So when you see f of g of x, I want you to think f outside g. So see how f is on the outside and g is on the inside, okay? And this is called composing the functions. So here's what it looks like. So we're going to go ahead and walk through, an example. So in example 4, I'm going to give you f of x equals 2x minus 1. I'm going to give you g of x equals 3x plus 5. Okay, so what we're going to do now is we're going to find f of g of x and g of f of x. So we're going to find f of g of x. We're going to find g of f of x. Okay, so the first thing you want to do if you're handed this notation is you want to rewrite it as this notation, which is generally going to feel more comfortable. So this is f of g of x, meaning f outside g of x. So what that fundamentally means for us is we're going to take, so if your brain wants to, what you can do is you can be like, oh, I'm just going to call this f of g for a second. So if you look at what f of g would be, right? F of g would be 3g plus 5, right? Like if I asked you for f of 10, you'd plug a 10 in for x. So if I ask you for f of g, you plug the g in for x. But then I want you to realize that the g isn't really just a g, it's a 3x plus 5. Oh, sorry, hang on. Take it back. Come on, brain. Look, I did a stupid thing. So we all do stupid things. Sorry, f, my bad, is 2g minus 1. See, we all have our moments, right? 2g minus 1. Sorry, I looked up and then picked the wrong function. So now my g is actually a 3x plus 5. So I get 2, instead of a g, I'm going to put in parentheses 3x plus 5, all minus a 1. Well, that means that this, if I distribute the 2, is a 6x plus 10 minus a 1. So I get 6x plus 9. So f of g of x is 6x plus 9. Again, ignore my snafu where I accidentally put the 3x plus 5. Now let's do the other direction, g outside f, right? So g of f. That's going to be g outside the f function, right? So what that's going to look like for our purposes is g and then plug in the letter f into the g function. Well, the g function is 3x plus 5. So g of f should be 3f plus 5. But f isn't really just an f, right? My f is a 2x minus 1. So what's going to happen is this is going to be a 3 times this 2x minus 1 plus a 5. So when I distribute that 3, I get 6x minus 3 plus 5. And I get that this answer is a 6x minus, or plus 2 rather. Okay, so there's my 6x plus 2. So notice that f of g of x and g of f of x don't have to be the same, right? So what we're going to do is I'm going to give you 2 more functions, and we're going to walk through in P4 you finding f of g of x and g of f of x. And again, ignore my stupid moment where I accidentally reversed the 2 functions. A thing to be aware of is that when I give this to you on an exam, or when any teacher does really, they're often going to give you a handful of functions, like an f and a g and an h, and ask you to do different things, like f of g or g of h or whatever. I know it sounds silly, but you saw how quickly and easily I made a mistake where I just accidentally picked the wrong function when I copied it. Double check, be careful, because again, the better you get at math, the more likely you are to make the dumbest mistakes where you just feel like, oh hey, I'm a moron and I can't read. I get you, right? It happens. The higher level math you do, the dumber the mistakes you're going to make. Don't beat yourself up about it, but do try to be meticulous, and when you catch a mistake, it's okay to own it and be like, man, I can't believe I did that. That feels really stupid, but hey, we all do it, okay? So let's do a P4 that's similar. So we're going to keep doing composition of functions. So for P4, I'm going to give you an f and a g, and you're going to find f of g and g of f. All right, so for P4, let's call f of x 5x plus 1, and let's call g of x 2x minus 7. Cool. So for A, I want you to find f of g of x. For B, I want you to find g of f of x. All right, cool. So I'm going to go ahead and walk through this. And again, if you want to pause me, that would be a good decision. So give it a try by yourself. All right, so f of g is the same as f outside g of x. Meaning, anywhere I see an x in the f function, and again, if it helps you to write it this way, you can, I'm going to replace x with g. So f of x will become a 5g plus 1, which is going to be 5 times 2x minus 7, in parentheses, plus a 1. So that seems to be a 10x minus 35 plus 1, and I think I get 10x minus 34. Right? For g of f, right, that's g outside f, if that's an easier way to think about it, right? So in the g function, I'm going to replace all the x's with f, so I'm going to get 2f minus 7, right? So that's going to be a 2 times the f function, which was 5x plus 1, all minus a 7. So when I distribute, I seem to get a 10x plus 2 minus 7. I get a 10x minus 5. Cool beans? All right, so now this can get harder as I give you a function that has multiple x's, and that's sort of where we're going to head in a minute. So before we do that, I want to talk about evaluating a composition of functions. So there are 2 ways to evaluate a composition of functions. So let's say, let's talk about evaluating a composition of functions. Okay, so let's say that I gave you f of x equals 2x plus 3, and g of x equals, let's do the square root of, let's do x plus 2. All right, so here's the thing. If I asked you, so if you are asked for f of g of 7, there are two ways to deal with this, okay? So you have two options. And I don't really care which one you pick, but I want to show you that there are two options, and that in some cases one of them is easier than others, right? So option 1 is to find f of g of x, right? Then plug in x equals 7. But since people tend to hate composition of functions already, like even just with an x, that's not always the best option. The other option, option 2, is to realize that f of g of 7 isn't that bad if first I find g of 7, right? So first I can find g of 7, right? If I wanted g of 7, that would be the square root of 7 plus 2, which is the square root of 9, so I'd get that g of 7 is a 3. Once I know that this is a 3, I can then say, oh look, that means that this whole thing is f of 3, right? And then I can use the f function, which is 2x plus 3, and say, oh, cool, so that's a 2 times 3 plus 3. Cool, that's 6 plus 3, which is 9. So I'm going to get a 9 either way I do it, right? But my point is that if I'm asked to find f of g of a number, like f of g of 7, f of g of 2, f of g of whatever, it's kind of easier to just find g of 7, plug in that number, find f of that number. Now, where is that not the easier option? Well, it's not the easier option if earlier in the problem you were already asked to find f of g of x. Like if you were asked to find f of g of x already in like part A, then in part B, if you're asked for f of g of 7, just plug 7 into the work you already did. But if you weren't asked to do that, then it seems harder. So now if I had picked option 1, let's just look at what option 1 would look like, right? If I had picked option 1, f of g of x would mean 2g plus 3, which would be a 2 times this square root, all plus a 3. So then, if you wanted f of g of 7, right, it would be 2 times the square root of 7 plus 2 plus a 3. Well, that's a 2 times a square root of 9, which is a 3 plus a 3. Oh, look, you still land at 6 plus 3, which is 9. Totally fine. Doesn't matter which way you go. What you find easier is not always going to be the same thing that somebody else finds easier, and that's okay, right? But it's something that we need to be aware of moving forward. We need to know our own strengths, our own weaknesses, and then try to make sure we do problems to the best of our abilities. Okay, cool. So let's do some composition of functions that's slightly more difficult. All right, so I think that we're on 5, but it's hard to remember. I think we're on 5. I think this is E5. I'm not 100% sure. I'm going to put a question mark, okay? So I'm going to give us f of x equals, let's do 2x, and let's do g of x equals 3x squared minus 2x plus 5. Cool. So now, what we're going to do in A is we're going to find f of g of x, and in B, we're going to find g of f of x. Okay? All right. Oh, sorry. I should have written it the other way first. I just got kind of lazy. Hang on. So I'll be honest, when I read this, my brain doesn't even think of it as this anymore because it's such a pain in the butt, right? My brain jumps right to the other version of it because it's so much more useful. All right. So let's do f of g of x first. So this is f outside my g function, right? Well, if you look at the f function, it's 2x. So this is just going to be 2g, which means it's going to be 2 times the entire g function, right? Which means I'm going to get a 6x squared minus a 4x plus a 10. Now, why is g of f of x harder? Well, there's lots of x's to plug in the g formula. So this is g outside f, which means in the g formula, I'm going to replace all the x's with f's. So 3f squared minus 2f plus 5. Well, that's going to be a 3 times a 2x quantity squared minus a 2 times a 2x plus a 5. Sorry, computer zonked. So now when I clean this up, I need to recognize that both the 2 and the x are squared, right? Because that's what we learned about exponentials, right? So I'm going to get that this is a 3 times a 4 times an x squared minus a 4x plus a 5. So I get 12x squared minus 4x plus 5. Okay? Cool. I'm going to give you a P5 that's similar. So again, we're finding f of g and g of f. Again, I'm not entirely sure that it's 5. It might be. It's hard to know. Sometimes I lose count on my own examples, as you've probably noticed. Okay, so my f of x is going to be, let's do a negative 3x. And my g of x is going to be 2x squared plus 4x minus 8. All right, and so for A, I want you to find f of g of x. Sorry, I do it every time. And for B, I want you to find g of f of x. Okay, so pause me if you want to do it by yourself. I'm going to go ahead and start doing it now. So f of g means f outside the g function. So if I plug a g into the f function, it's just negative 3g, right? Which is negative 3 times this 2x squared plus 4x minus 8. When I distribute the negative 3, we get a negative 6x squared minus a 12x plus a 24. The harder version is going to be g of f, right? So g outside the f function is going to mean 2f squared plus 4f minus 8. Which is going to be a 2 times this negative 3x quantity squared plus a 4 times a negative 3x minus an 8, right? So first thing to remember is, as we've seen before, that the squared goes to both of these numbers, right? The negative 3 squared is going to be a positive 9. So I get 2 times 9 times an x squared minus a 12x minus an 8. So I get 18x squared minus 12x minus 8. Cool. All right, so we'll stop this video here, and then we'll do some more examples in the next video.